All right, we're rolling. So for you guys at home, we got everybody here. We should be done with chapter R. The chapter R review is up in Course Compass, so you should be working on that. I'll open the test midnight this Thursday night, so you have until Friday morning through Tuesday, I believe, or through Monday night to do the test. So you've got plenty of time to work on that test. So we're moving on into chapter 1, section 1.1, number sets, PEMDAS, scientific notation. So let's look at the sets of numbers, and we're going to just get started with real numbers, and then we'll talk about what imaginary look like, but mainly the basic way to label numbers and what we call them. So who knows what are the most basic set of numbers called? Like when you're a kid and you're in kindergarten, you're learning how to count. What are the first numbers they teach you? Yeah, 1 through 10, 1, 2, 3, 4, 5, 6. And hopefully you can move on from there, but those are called the natural numbers. So when we label everything with we use a bold-faced capital letter. You have natural numbers, which are labeled with a bold-faced capital N, and they go 1, 2, 3, 4, 5, forever. Okay? I call them caveman numbers. 1 stick, 2 sticks, 3 sticks. I'm making fire. So for sets, we use the braces. So those are the natural numbers. Okay? Then, after the natural numbers, this concept of zero was introduced. So how do you label nothing? Well, they use the number 0. And when you add the number 0 to this set, they're called the whole numbers. We use a bold-faced capital W. So the whole numbers are 0, 1, 2, 3, 4, etc. Okay. All right. And then with football, we had another set that had to be developed for football. What do you call it when the quarterback is sacked 3 yards behind the line of scrimmage? Yeah, but the yards, 3 yards behind the line of scrimmage, the quarterback is sacked. Negative 3 yards is what happened, right? So it's a 3-yard loss or negative 3 yards. So what are the whole numbers and their opposites called? So 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, and so on. What are those called? Integers. But yeah, integers weren't developed for football, but we use them, so it was a joke. We use boldface Z. So negatives. Anybody know why we use a Z? I know Allison probably, I think we talked about it last year. Yeah. So Z, we use, I is not used because it's used for irrational, which we'll talk about in a second. But Z is used because it comes from the German word for numbers, which is Zahlen. So that's what it comes from. Now, what I like to do is as we are, go around that here, I don't run out of screen. Okay. So what I like to also do is use a Venn diagram for our number set. So just to kind of show. So if I start with just a set of natural numbers, just say they're all in that circle right there. Where would I put the whole numbers? Would I put them over here somewhere separate? No, around. Because the whole numbers contain the natural numbers. See, so I can use Venn diagrams like this to show. But what number would be in here That's not in the n.
0.
0, very good. And then do the integers contain the whole and the natural? Yes. So the integers would contain those. And what would be in the integers here that's not in the whole or the natural? What numbers would be in this part? Those would be the negatives. All right, these are your negatives. All right. So I like to kind of show it like this. The next set of numbers are called the rational numbers. And we use a boldface capital Q for rationals. Also think of them as ratio numbers. There's two ways you can look at it. It's a fraction, so we don't really put a set of numbers like that. It can be a fraction like this, where it's any integer over any integer, except the bottom can't be 0. Or it's a repeating or terminating decimal. Either one. Any integer over any integer, or repeating or terminating decimal. Okay. So Hank, pick 2 integers for us. Just pick us 2 integers. So go back to your set of integers, look at what integers are, pick 2 integers.
1.2.
1.2 is not an integer, so let's try again. I'm asking for you to go to the set of integers. Here are all the integers. I just need you to pick 2 of them.
Oh, 1 and 3.
I'll plug them in. So it is 1 over 3. An integer divided by an integer is the definition of a rational number. So 1/3 is a rational number. I'm trying to show you how this definition fits. So 1/3 would be considered a rational number. Its decimal is 0.3 repeating. Notice it has a repeating decimal. So anything that fits integer over integer is a rational number. All right? Paige, pick 2 integers for us.
-3 and -2.
There you go. So -3 over -2 is 3/2, which is 1.5. That's a rational number, okay? Notice that decimal, we say what? Terminates. It's either a repeating decimal or a terminating decimal. Now, I could have picked 8 over 1 and gotten 8. By definition, 8 is a rational number because 1 is an integer. -4 over 1, which is -4, that's a rational number. So my question is, do the rational numbers contain all the integers? Yes, they do. Because if I divide by 1, I have an integer now. If 1 is on the bottom. Okay? So your rational numbers contain your integers. Okay? So what if they put a decimal like this? What if they put 0.1811818? Let me just do 18181818. So what do you call that?
Repeating decimal.
Repeating decimal. So is that a rational number? Yes. So you gotta also be able to look at the decimal in them. Okay. Guess what set is over here? That's not a rational number. Irrational numbers. Running out of room. You have irrational. And irrational numbers are given by boldface I. And the best way to say it is non-repeating, non-terminating decimal. That's the best way to write an irrational number. So irrational are over here, and all of these together are your real numbers. Okay? So here's how it works. I'm gonna put a number on, what is the most famous irrational number you think there is? Pi. Pi, it's like 3.1415, yeah, I don't even know what the rest of it is. It just goes forever. That's irrational. Square root of 2 is irrational, square root of 3, those are all irrational. If you get the, you'll see the decimals never repeat, never end. Okay? So, here's how it works. I write a number on the board. You say what all sets it belongs to. Okay? I'm running out of a little room. So I'll go, let me erase this work here. And I would just write the letter that corresponds. I wouldn't try to write the words. You know, I would just, so I'm gonna give you a number, you tell me what all sets it belongs to. Oh, on these, don't worry about real, because they're all gonna be real numbers. So example 1, give all number sets that each number belongs to. All right, ready? So if I don't put a bar, it means it doesn't repeat, okay? So you're gonna list for each number, so you're gonna ask yourself, is 4 natural? Okay, yes or no, you put it. Is 4 whole, is 4 an integer, is 4 a rational number, is 4 an irrational? And you're gonna list by each one, put all, so I would put, so let's just at least answer the natural. Is 4 a natural number? You're gonna put an N, just to save you some writing. Then you move on and you say, okay, is it whole? And if it is, you put a W. So you list out all that it belongs to. Okay, if it doesn't belong to it, don't list it. Okay, so let's check. The number 4 is what? What would you say 4 is? Natural, yes. Is it whole?
Yes.
Is it an integer?
Yes.
Is it rational? Yes. Is it irrational?
No.
You can't be rational and irrational. They're either one or the other. -10, is it natural? No. Is it whole? No, is it an integer?
Yes.
Is it rational? Yes, because it's negative 10 over 1. It matches the definition. All right, 4/3. What is it? It's only one answer. Rational. 1.278913. What is it? Irrational. Okay. All right. Any questions on that? So there you go. That's the type of questions you'll get with the number sets. Then the rest of this is pretty easy. I'll just do a quick reminder on PEMDAS. All right, so if I put something on the board, just to go deal with this. So PEMDAS. So I'm not going to write them all out. I think you know what each letter stands for. What does the P stand for? Parentheses. So if we're trying to work that expression out, the first place we go is inside the parentheses and we work that first. So the first thing we should do is do 8 minus 5. Well, what do you get when you do 8 minus 5? 3. All right. What's the next thing you should do?
Exponent.
Exponent. So the E stands for exponent, so you have an exponent, you turn that 3 squared into a, 3 squared becomes 9. All right, so here I did the parenthesis first, here I did the exponent. Now, do I do 7 minus 4? Do I do negative 4 times 9, or do I do 9 plus 11? What do you do? No? What's the next letter?
Multiplication.
M, multiplication. You do multiplication. The M stands for multiplication. You do multiplication before you do subtraction or addition. So now you do 4 times 9, you get 36. And then you can just work left to right. On addition and subtraction, it doesn't matter. All right, the D stands for what if you had it? Division. So you can do 7 minus 36 and plus 11. So you get negative 29 plus 11 is negative 18. Okay. So that's order of operations. You'll get some practice with those. I don't think we need to spend too much time on that. Just a little refresher. Okay. All right. So the last thing I want to kind of talk about is scientific notation. So we'll go from expanded form, or from scientific notation to expanded form, and then from expanded form back. So let's say we had 7.42 times 10 to the 5th. Okay. So first of all, this is in scientific notation. All notation means is just a different way to write something. So the notation means we're going to use this notation, which is just a different way to express something. So let's put it in expanded form. So what this means is that, okay, if I have 7.42 times 10 to the 5th, that means times, what would 10 to the 5th be? That would be 5 zeros. So that's like 100,000. So it means do 7.42 times 100,000. Well, I don't want to try to do that in my head. So basically the rule is if you just take the decimal point and move it 5 places to the right, that's what your number is going to be. So I'll put zeros there and I get 742,000. That's the expanded form. Okay. And if I want to go, so we'll do a couple of going from scientific notation to expanded. If the number is less than z, if it's a negative number, you move the decimal left. Okay, you move it that many places left. So if it's a negative 4, that means you're going to take the decimal and move 1, 2, 3, 4 places to the left. So you get 0.0003. create. Okay? So a positive, we move right. And a negative, we move left. Okay. Then the other part is going from expanded form back to scientific notation. So let's say I have 8,320,000, like this. This is the number I have, okay? So right now my decimal point is here, all right? So let's think backwards for just a second. In scientific notation, you know it's going to be 8.32 times 10 to the something. The question is it going to be a positive number or a negative number? Positive, because you know it's a big number here. It had to move this way. So what I do is I just go back to see how many places it moved, but I know it's going to be a positive. So it's 1, 2, 3, 4, 5, 6. This number in front in scientific notation is always a number between 1 and 10. Okay? So here's how you do that. And then let's say we have 0.000017. Okay, that's what we have. So I know whatever it's going to be is going to be 1.7. So always this first number here in scientific notation, this first number is between 1 and 10. It's like a 1 point, 2 point something, 3 point something, so on. And I know it's going to go times 10 to the what? Well, let's see how many places. 1, 2, 3, 4, 5, 6. Now the question with this, is it going to be a positive 6 or a negative 6? Negative 6, because you know it's a smaller number. And that's just a little crash course on scientific notation. That's really it to this section. Your number sets, you'll do a couple of order of operations, which I don't think is that bad for you, and then there's your scientific notation. Okay. Any questions about that?